together.
Okay. That makes sense. I'm going to write that down. I always forget those subjects are different. Common.
Although there was that one problem in one of the quizzes. I think Wes was talking about this one time that the whole, what do you call it? I think they were like the brother and the sister.
I remember that. We went over that for a while.
Yeah, I don't remember. Did we say that I was independent or dependent?
I don't remember either.
If you choose one of the siblings, then you have to automatically choose the other.
So it was dependent?
Yeah, that would be dependent.
Okay. So when one subject is dependent on the other subject.
Yeah, or the choosing of one is dependent on the choosing of the other.
Okay.
Haha, Major Tom. Major Tom. My friend looked it up. There's no such thing as a silverback.
Marilla?
No, there is such thing as a silverback.
Is that a song or a movie or something?
Soon watch your video.
Good night.
Almost 10:30.
Yeah.
We're gonna put that
Yes.
I got it wrong. I got like a 75% on this.
Don't laugh at my score.
That one was wrong. It had to have been G.
Did you already
Or no,
get it?
two.
You already turned it in?
No. We said A for that one anyway.
Well, use your resources. Hey, don't waste my diary.
So I thought number 3 was G because it's talking about it's talking about whether older or younger than 40 years old, but then they wanted to report the number of employees in each group who were terminated. So technically that could be a proportion. I just didn't know if it was G or D. D.
I guess you're right because there's two proportions there. I didn't think about that.
So it'd be like the. So it'd be like the number of the number of terminated to the total of the group of people that were over 40, or the percentage or the proportion of those who were terminated out of the total number of 40 and younger. So I guess it could go both ways. That one's kind of a. That's just what I thought. Why I thought it was a proportion.
Well, we could see if the independent fits in any of the other ones, because I don't think they would be a repeat. Do you know what I'm saying?
There's only 4 of them, so.
Oh, yeah.
So number 4 I thought was F. Because it's the proportion of proportion of males. They say that it's 48.5%.
Yeah.
You ran it? You ran it and it didn't leak?
But did you say F or?
For number 4, yeah. Is that what you guys thought?
Well, they have 2 proportions here. Oh, I guess it's testing it against the actual male population, assuming that the proportion is 48.5%. Okay, I could see that. I could see F.
time you're running it?
Oh, I thought you were saying I needed to let it.
I think 5 is a paired sample t-test.
Yeah, because you have two different sets.
Because you have the same subject but 2 different lots.
Yeah.
So you want to see if there's a difference in time between the 2 lots.
To open each lock. Yeah.
So which one did you think it was?
I think it's paired.
Paired.
Yeah, okay, sweet.
Huh.
Cool.
And then,
Okay, confidence intervals, yay.
no. So, one sample, I think employs 2 appraisers. And is impeded.
Hmm.
So we're looking at, so there's 2 different appraisers.
Paired sample t confidence interval?
Hmm.
Because you're taking the same properties, but with 2 different appraisers.
You know what? But I think, you know what I think? I think, so I don't think they're comparing the 2 appraisers. I think each of the appraisers is compared to themselves. I don't think they're comparing the difference between the 2. I think they're just comparing them individually. Because they just want to see that the appraisers value the same type of properties consistently. So I would think that one would be like an independent sample confidence interval.
Okay.
But it makes sense that it's a paired sample because you have two appraisers. Each of them is specific to a property that they estimate or appraise.
So
They just chose 6 properties that
Yeah.
both appraisers had recently valued. So there's only 6 properties that they did.
Yeah, they're
But-
comparing.
So they both appraise the same properties.
Yeah.
Then
Yeah.
it
That's what I
should
got
be
from it.
then it should be paired sample, I think. C. Yep, I think you're right, Kyle.
They're just comparing the. Here's the career path. It's also reported.
So this one, is this one paired as well?
Well,
But
Well,
it's a
proportion, I
percentage.
think.
yeah, it's a proportion of the.
Yeah, so because there's a percent, and they do a percentage, yeah. So it'd be
2
2?
proportion?
Yeah, I think so.
So F. Double stuff.
So you're comparing the. Let me take a sample. So you're comparing the double stuffed with a normal amount.
Mm-hmm.
I feel like that'd be a really hard test to do.
I know, yeah. Would you like weigh it or something, or what? I don't know.
I don't know how you do that.
I don't know. I like our study better.
Yeah.
Use count.
What is a one sample Z confidence interval again? You guys remember? Because I don't.
The Z confidence interval is when we don't know the mean for the population mean, but we do know the standard deviation. So I would actually think it's a one sample T confidence interval. Because we don't know the standard deviation and we don't know the mean.
Yeah, that's what I thought. Alright, computer, what are you doing? Alright, significance level.
That's a probability of observing a sample statistic more extreme than the other, even though one actually obtained. Isn't that?
I think that's p-value.
Oh, that's p-value.
I think.
I think this is the probability of either rejecting the null hypothesis, whether it's true or not, or the probability of a type 1 error.
See, type 1 is we reject when it's true. Is that right?
Mm-hmm.
I guess we could Google it.
Oh.
Well, that didn't help.
I'm gonna guess the probability of rejecting. I don't remember.
Yeah, I think significance level is the probability of rejecting the null hypothesis when it is true. 0.05, 0.01, so on and so forth.
So 9 we're saying it's the rejecting.
Because the p-value is the probability of observing a sample statistic more extreme than one obtained, assuming the null hypothesis is true.
Yeah, that's number 10.
Is that what you think, Kyle?
The rejecting one?
Yeah.
Yeah. you know, the probability of a type 1 error is kind of. I just want to make sure it's not that one.
Yeah. I'm pretty sure it's in one of the reviews, isn't it? In like review.
Would it be the last review that we did?
Yeah, probably.
Oh, right here. Sweet. It would be. Oh, it just shows the 16 through 19.
Bless you. Yep.
Okay, yeah, I think it's rejecting. I think that's right.
Oh, there it is, right there.
Did you find it?
No, I was looking for the review, like this flowchart thing, review sheet thingy.
This is exam 4?
3.
No, exam 3. Okay, so I think it would be in the last exam. Jazz. Level of significance is a standard of determining whether or not the null hypothesis should be rejected. Okay, there we go. I'm taking that one. So, but it says also that the value of alpha is the probability, or the value of the level of significance. It's the probability of committing a type 1 error. But I don't think that that's the real meaning behind the level of significance. That's not what we're really trying to look at.
Right.
So alpha is the probability of committing a type 1 error? Is that what it says?
Yeah.
No, the probability of rejecting the null, whether it's true or not.
The rejecting the null is the type 1 error.
Yeah. In the lesson 9 review thingy, it says that that's what it says for the level of significance, is the standard of determining whether or not the null hypothesis should be rejected.
Okay.
And did you say it said something about a type 1 error?
So it does say that the value of the level of significance is the probability of committing a type 1 error, but I don't think that's really what we're focusing on with the level of significance. When we think about the level of significance, we want to focus more on the, I think on the, whether we're rejecting the null hypothesis or not.
Okay.
Looks like Kendra's just as tired as I am.
I'm ready. I'm ready for the holiday.
Are they gonna have school off?
Yeah, we don't have Friday. We don't have any
Nice.
classes on Friday.
That's awesome.
Mm-hmm.
That's ridiculous. Not even for a country's birthday.
Is Friday July 4th?
Yeah, no, Saturday is this year.
Okay, that's what I thought. All right, so 11, I think, is a 95% of all 95% confidence intervals actually contain the true mean. Because I think that's always, they always ask this question.
Yeah,
Yeah.
that's what I put. 12 is 0.30.
Yeah. I think. Of the sample proportions.
Yeah.
So yeah, I guess that's right.
Okay. So if it's 0.30.
How do we find this again?
Okay. I got 0.4458 for the standard deviation. Let me know what you got.
I forgot how to do this. Is this just the
That's the P. What is it? P times 1 minus P over N square root it all.
1 over P minus N?
No, like the P times in the parentheses 1 minus P parentheses over N, and then the whole thing's square rooted.
I forgot about that. This would be a one sample proportion test or whatever.
What'd you all get for 12? Oh, yeah, it's a one sample proportion.
Mm-hmm.
Okay.
For 12 or for 13?
For 12.
So just going to be 0.30.
I would think 0.30.
Oh, sorry, not 12. Oh, for 12, are we going for 0.30?
Yeah.
Okay.
That's what I think it is, yeah. With 100 adults.
So, not, or yeah, I got, oh.
I got 0.046.
Yeah.
Okay. Or
Well, you would, if you round it, right? I mean, that's.
yeah. Okay.
How did you guys do this one?
So 0.3 times 1 minus 0.3, which is 0.7, divided by 100, and then you square root that.
Okay. Wait, this was for 13 or 14?
This one's 13.
Okay, yeah, okay.
How do we do the proportion? Sample, what is the probability?
So you take the, so you'll take x bar, I guess you could say. Or no, sorry, p hat. And you subtract p, and then you divide that by the standard deviation that we just found.
Oh.
Without rounding. So you got to do that whole.
4. Is that? Okay. So P.
So when you do the standard deviation, you can't round it.
Okay.
So I got -1, blah, 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 and we need the probability applet.
Oh, man.
Okay. Alright, I got 0.138.
I'm trying mine again because I didn't get that the first time.
Okay. Did you get -1.091 for the z-score?
No.
thing?
So I knew it wasn't gonna. I'm wondering if I.
Oh, no. Dang you. Dang. Well, yeah, I don't know how to do this one at all. Sorry, guys. Is this from the last test?
No.
Oh, this is from this unit that
Yeah.
we've been doing.
I
This is
think
the one sample proportion.
Yeah, I think it's lesson 16, if I remember.
It's like 16 or 17 or something.
Yeah.
Yeah, I don't remember any of this. It's alright though, don't worry about it. I'll figure it out.
Do you know this equation here? Is that backwards for you?
No, that's
See?
right.
Okay, that's the
P hat minus P over standard deviation.
Standard.
Cool.
And to find the p hat, you just do the x over n.
yeah.
But how would you get x in this question? Because it gives you n, like 100 is n.
Well, on 14 they give you that. It's 0.25 is
Oh,
p
gosh,
hat.
that's why. Okay.
I'm supposed to be the tired one here, not understand this stuff.
What did you guys get for the z-score? Sorry?
I got negative just now, negative 1.091.
Okay.
I don't know what
Well, you said negative 1.091?
Yeah.
Yeah.
Okay.
Mm-hmm.
Um,
Oh man.
Oh. Going crazy.
so I finally got that one. Around 15.
Yeah. Did you get 0.138?
Yeah. And
What, Wes, did you figure it out?
Yeah, I got that as well.
okay. And then the point. Um, not.
Oops.
Is 16, is it the null does not equal the alternative?
I don't know. I'm doing 15.
Oh.
Which you can do. This is the two proportion thing.
Yeah, I did it. I got the 0.003 and 0.029.
Okay, I'm just behind.
Yeah, that's what I got too.
Okay.
And then I put P1 is not equal to P2. Yeah, that's what I put as well.
Okay. Yes. 17, I got 1.458.
You said
okay.
P1 is not equal to P2.
Yeah.
Yeah.
You said the value of the test statistic is what?
1.458.
Mm-hmm.
1.458. And then p-value is point.
Zero. Yeah, 0.072 is what I got.
I got 0.145.
Yeah, Kendra, I think you got to make sure that you're testing for not equal to. It automatically does like less than, I think, or something like that.
That's what I didn't do.
But you'll be right on if you change it.
So we failed to reject the null? Excuse me.
I don't know. I feel like on the homework assignment I did that and it was wrong because they always talk about accepting or rejecting the alternative.
Yeah, oh.
But I don't really know because there's yes, I failed to reject the null, and then there's no, I failed to accept the alternative, and basically those two mean the same thing.
Yeah, but I think it's usually failed to reject the null hypothesis.
Okay. Yeah,
I think we only state the thing in terms of the null, and then the rest of it we don't worry about.
Okay.
And I think that just makes it simpler just to talk about that. I still don't like the fact that they say failed to reject.
Right.
But
right.
But yeah, we just talk about the null for that, and then from that we just automatically assume that we, reject or failed to accept the alternative or rejected it.
Yeah.
Hey, we're almost halfway through.
Woohoo.
So this next one, we're gonna have to do the chai thing, huh?
Mhm. Yeah.
Oh.
Bless you.
So for the test statistic, I got 6.58.
Oh my goodness, what did I do?
And then the p-value I got.
I got some super crazy high number. But I typed it all in, right? What did I do wrong? Alright, if I do that, how'd that change it? Oh, okay, I got it. Never mind. Going crazy, losing my mind.
What did you have to change?
I just had to hit enter.
Oh.
Because it didn't take my last number because I didn't hit enter yet. So I got 0.087.
Yeah, me too.
So with that, we failed to reject the null because it's greater than the p value, the level of significance 0.05. So reject it.
Greater.
No.
Yeah. The P is low.
Yep. I think.
No p-value is greater than 0.05. Have
What do we conclude based?
insufficient evidence to say that being a morning or evening person is independent of age. Okay. Is that right?
Yeah.
Wait. Yeah, okay.
Is independent. Yeah.
Wait, what did you guys do for 23?
Wait, how do we state that? What's
Could
the null and stuff for that thing, that test?
being a morning or evening person is independent of age is the null.
Does it state that? Oh, it does state that. Okay. Okay. Yeah.
So it should be we have sufficient evidence to say that being a morning or evening person is independent of age.
Yeah. Yep.
So basically we're just restating the null because the p-value is greater than the...
Well, no, we can't say that yet, I don't think. I think because we're testing for, I don't remember this stuff.
Because one of them you just talk about the alternative hypothesis and proving it or not proving it.
Yeah.
Basically saying it's independent. It's not independent.
If we reject it, then our conclusion would be sufficient evidence to say that they are not independent.
Okay.
So if we fail to reject it, we have insufficient evidence to say that they are not independent.
But they are not independent.
Okay. So yeah, this one should be not independent. Okay.
Congratulate. Is this something that you do with chi as well? Number 24? Or?
I don't think so.
Okay.
Because the chi is a test for independence. So it's not asking for independence, I don't think.
Yeah, so this one would be a 1 proportion, right?
200. Random sample of 200. Okay. 200.
Okay. So 50. I don't like how they put
What do you put for the null?
so the null is 0.2. So 20%, 0.2. The x is 50.
And the n is 200?
Yeah.
Okay. So it's the 0.190. Okay.
So yeah, 0.190 and 0.310. Suppose you had been designing stuff.
Suppose you had to be in charge of designing a study. What sample size would be needed to construct a margin of error? Here's the bar. Oh. Here's the margin of error. The last one was that one.
Margin of error. Where are you? Ah, 2 proportion. That's not it.
Yeah, they're doing the tire thing.
I think I might run it and get the sprinklers that I need to first thing in the morning and start watering here. Are those running all the time? Yeah, sprinklers going all the time. Right?
That's what Tara's been I would just grab what you needed and help.
Okay. Sorry about
There it is. Okay. So n is equal to, well, what do we know? Is it
But we're trying to figure out
All right, so n is equal to z over m, square all of that, times p times 1 minus p.
Dividing 0.96 over.
So 95% confidence interval, we have to use the 1.96.
And are we using 0.2? 0.2 for the margin of error, right?
Yep. The 0.02.
Oh yeah.
And then I get 1537.
Sorry guys, my calculator died on me.
Oh no.
It happens.
6 divided by 0.2. Squared equals 4 times.
Oh crud.
And we round, right? So it's 1537.
Yeah, you have to round up.
Okay. Did you get 1537?
Yep.
Sweet. One. Go away. I just got scared. It's not funny.
Scared me.
No, I'm doing my study group. What do you guys want? It scared me so bad.
I wanted to say hi.
No.
My study group is I don't know, it's because it's a review. We had like 40 questions. We have about 13 left.
Oh,
Is it cloudy everywhere?
no, it's not.
Okay, as soon as I'm done,
Kyle, so for that last one, to find the sample size, did you just do 1.6 divided by 2% or 0.02, square that, and then you multiply that by,
blanket.
let's see, 0.2 times 1 minus 0.2? Is that how you did it?
Yeah. I've got the equation here. Can you see that? I think that's right. Yeah.
Yeah, so I don't know. I just must have plugged something in wrong. I got a different number, but
Okay.
I did the same equation, so I don't know.
In my bed.
I would do that.
Okay. I'm gonna be sitting on my bed. Sorry.
It's all good.
Are we still on 25 or do you guys move on to 26?
Well, I think Wes is still trying to get it. I don't know.
Yeah, I'm good on 25.
Okay.
26, I said that P is greater than 0.2.
Okay.
Yeah.
How many measurements must be? So do we need, so for the P to be normally distributed, we need the hypothesis test? Right?
Yes.
And that is NP is greater than 10?
Is NP greater than 5?
Oh, it's greater than 5. Why did I think it was 10? I don't know.
Because before it was 10. I don't remember why they changed it. Oh, sorry. No. What am I smoking?
It is 10?
I think for chai it's greater than 5.
It's 10.
Okay.
Okay. Chai, it's greater than 5. Sorry.
Okay, I was like, what happened?
So NP greater than or equal to 10, and N times 1 minus P has to be greater than 10, right?
Yeah.
Okay. And that's for 1 or 2 proportion test?
I believe so.
Yeah, 1 and 2 proportion test.
Cool. Okay.
But chai, we don't use that. Why did I think it was 5?
Chai is 5. I think all the digits, I think you're right for chai. I think all of the numbers have to be greater than 5.
The expected count must be greater than 5. Greater to or equal to 5. Greater than or equal to 5. Sorry.
Okay.
Okay. Now I know where that came from. Alright. I got test statistic as 1.768
Okay.
and p-value of 0.039.
Sweet.
Oh, we're almost done.
The p-value is less than. So when it's less, where did I see my notes? So we reject the null?
Yeah. I said yes, I rejected no.
Okay. Oh man, what is 31?
I don't know. That's a long thing. I don't want to read it.
Assuming. So we're calculating the 95%
This one.
interval. This is an old lesson. This is from the last test.
Mm-hmm.
Oh man, what? Okay, confidence intervals. Where did I write that down?
Is there a... Oh yeah, we gotta open the data file.
I really just like this proportion testing on SPSS.
Yeah.
Is it under blue? Blue scores?
It is, yeah, blue scores, yeah. Okay.
Oh, dang it. Mine won't open unless I'm in the ES or SPS, and I can't be in the SPS and talk to you guys at the same time.
That's understandable. My SBS test is coming up. It's slow.
So this is going to be a t-test because we don't know the standard deviation. Is that right?
Oops. 1 second. You suck.
Oh.
Yay, it came up. Okay. So. Is it independent t-test? I guess it's just a t-test.
I thought it was just the one sample. Yeah, one sample t-test.
Okay. But do we have a mean for it or anything? Oh, mean score of 0.295. Okay.
Yeah. Oh, come on now.
Okay. All right. Let's see here. All right, I got some weird number. All right, so I got -0.013 to -0.002. See what Wes gets.
Yeah, my computer's being slow. Typical. Oh, baby. Alrighty, almost there. Alright, come on.
Oh, my footage is. Oh no. 50 foot. Ah.
Crud. Man. You know what? Oh my gosh, it's killing me. I can't find the data files. I'm trying to find it here. I'm opening all those old study things, whatever they're called. I can't think right now. There we go, there's one. Oh. Okay. What are we after first?
The confidence interval.
Yeah.
I got negative 0.013 and negative 0.002.
That's what I got.
Your dad had keep landing. He feels like he can do more than he did.
Sorry about that,
Did
guys.
you not end up taking the truck?
Alright, so the DF is 99.
Yep.
Put it in the back of that.
T value would be
See you,
negative
Wes.
2.83. See you guys, love y'all.
Yep, that's what I got.
See you, love ya. .803. Just negative 2.803. Okay. And then let's see, is this
You said the p-value is 0.006, right?
yeah.
Okay. So we have insufficient evidence to say that the true mean is different than 0.295.
Okay.
So we're rejecting the null, right?
Yes.
Because it's more, yeah. When it's below, you reject. When it's above, you fail to reject.
So in this case, we have sufficient evidence to say the true mean is different than 0.295. Is that right?
Yeah.
Okay.
Oh, I'm sorry. Yeah, we have sufficient evidence to say that the true mean is different than 0.295.
So now we're doing the AM PM heights. Okay, so we gotta do the differences.
So it's a paired sample t-test, right?
Yes.
Okay. Just want to make sure I did it right.
So then should be paired sample t-test, yes. Okay, so let's see. So for the confidence interval, 8.728.
Yep.
And there it is, 10.455.
Yep.
Two. $22.446, right?
Yes. Degrees of freedom 40. And p-value I put 0.000.
Oops. And then 0. Yeah.
And then 39 I said yes because we rejected the no.
That took a while.
Oh.
Sigh of relief.
Well, I can say that wasn't our shortest test review.
No.
That was long.
It's 39 dang questions.
Gross. Shoot. Well, should we run through them then?
Let's
Yeah.
do it.
It's over with.
All right. So number 2, we're thinking it was H. Number 3, G. Number 4, F. Number 5, C. Number 6, C. Number 7, F. Number 8, B.
No, it froze.
You good, Kyle?
Almost. My computer
Okay.
froze.
Yeah.
You just let us know.
At your house?
Okay, we're good. Alright, we said 5C, 6C, right?
Yeah.
7F.
Yep.
Alright, you want to go ahead and keep going.
So 8B. 9 is the probability of rejecting the null.
Yep.
10 is probability of observing a sample statistic more extreme than one actually obtained.
Okay.
Number 11 is 95% of all 95% confidence intervals. Number 12 is 0.3. Number 13 is 0.458.
I put 0.046.
That's what I put too.
Okay, I just probably was spacing.
The reason you did that is because it's supposed to be 0.0458. So there's just a 0 before it.
Oh, yeah, okay, yeah.
And then you round it, so.
Cool, okay. So 14 is 0.138. Number 15 is negative 0.003 to 0.029. Number 16 is P1 is not equal to P2. Number 17 is 1.458. Number 18 is 0.145. Number 19 is no, I failed to reject the null.
I wouldn't doubt it.
Number 20 is 6.58. Number 21 is 0.087. Number 22 is no, p-value is greater than 0.05. 23 is we have insufficient evidence to say that being a morning or evening person is not independent on age. 24 is 0.190 to 0.310. Number 25 is n is equal to 1537. 26 is null is equal to 0.2 and alternative is p is greater than 0.2. 27 np is greater than 10 and n multiplied 1 minus p is greater than 10. 28 is 1.768. 29 is 0.039. 30 is yes, I rejected the null. 31 is negative 0.013 and negative 0.002. The df is 99 for 32 and the t is negative 2.803. Number 33 is 0.006. 34 is we have sufficient evidence to say that the true mean is different than 0.295. 35 is 8.728 to 10.455. 36 is 22.446. 37 is the df is 40. 38 is 0. 39 is yes, because we rejected the null.
Alright. I think it's my turn.
Okay.
Oh my goodness.
94. Oh no.
What?
Number 9.
Number 9.
Oh really? Significance level. Dang it all. So it's a type 1 error then.
Mm-hmm.
Shoot, dang. Was that the only one?
Number 31.
31.
Yep.
Oh man. Let's see, we both got that one there.
Yeah, it's kind of weird.
Blue scores. Number 31. Is it 0.013 and 0.002? Both negative, sorry.
Yeah, that's what I put. Negative 0.013 and negative 0.002.
Let's see. And negative 0.013 is less than, or the lower bound.
Unless they're supposed to be reversed.
Let's see.
I can try that.
Well, no, actually, that doesn't make sense. I think it's fine the way it is.
Let's see, and we tested it against point. 0.295.
Hi, Miss Steve in high school. I'm working on a project for our local food bank. I need a quote on how much a 2x16
.013
Put a 2 foot by 16 foot.
and .002.
Maybe
I-
it,
And then we just add, could you please,
I don't know what to say.
yeah. Maybe it's an error because sometimes I've had in a few classes with math I've had like
the price difference.
problem was wrong and she went back and corrected it. Slim chance, but that might be the case here.
Those are the only ones though. 31 was wrong, huh?
I'm gonna try something real quick here as soon as this loads back up again. Try doing it again, but let me see here.
You would suggest?
Where is this?
You might
It's
wanna
marked
say just-
back here.
FYI,
Yeah.
So you plugged in the population mean. Try doing it without the population mean, just having it at 0, and see if it gives you a different answer.
Yeah, it does.
Do you think it might be that?
Send?
Oh, does it have your information on it? Make sure you put Cody's name.
Well, I don't know. That would be, I guess, the only
Do you
thing.
wanna look through my
But we
email?
are testing against .295. I don't know.
Just copy and paste it right into your email. If you wanna send it to you or put.
That'd
I
be
guess-
the only,
I guess-
that'd be the only thing that I could think that could maybe make it different.
That'd make sense for.
Oh, and then on their lunch, put,
But then the T value for this one is 109.
Yeah, the T
Which
value
doesn't-
will change. I think, because I remember
Which
I
doesn't make
kept getting
sense.
this wrong, and I think that might be the reason. I think the confidence interval, you have to put it at 0, and the t-test, you have to test against the .295.
So I should do the same. Just put in 0 for the testing against, huh?
Send?
would you get it to me?
Cool.
I'm a senior in high school. I'm working on a project.
Well,
for
I
our
guess
local
let
food
me
bank. I need a
try it
quote on
and
a
see if
16 sign.
.282.
And please include the different price materials. The different materials?
The different prices and, the different prices for different materials. The different-
And what
the
you would
different-
suggest, the sign will be facing south.
That's what it was.
Okay.
Yeah, so it was .282 and .293.
Tomorrow morning.
Well, there we go. Now we know that.
But we got our test statistic right for that.
Yeah, so the I think the test statistic is when you have to use the .295, and when you use a confidence interval, you have to use 0.
Oh, jeez. I don't remember doing that.
Well, I remember I always got it wrong. I always
Really?
had the problem with the quizzes and I think on the test as well
Really?
with that exact problem, and I think that's probably why I kept getting that wrong.
I see.
Because I would get different things wrong. I never realized why, but anyways. But now we know.
So Kendra, did you get that? The
Yeah,
numbers?
you guys. Yeah. I was listening to you guys.
Okay.
So,
Sweet. Okay.
Oh, crap. I got a bad grade on my physics exam.
Physics.
All right.
Yuck.
well, I'm gonna head, but
Yeah, it's been a long evening.
guys. Yeah, good luck. And I don't think we meet till Tuesday.
Yeah, I think you're right.
So.
Yeah, well, have a great 4th of July.
Yeah, do something fun, something crazy.
Yeah.
It was funny that being at the lake today, the lady said, this weekend's going to be crazy, or it's going to be busy and stupid.
It's funny. All right. Well, have a good one.
All right, you all too.
You guys too. Take it easy.
All right, bye.
That's it.